Hi students, this is our third problem related to spur gear. I can read the question, please listen. In a spur gear arrangement of a pinion made of cast steel is rotating at 900 rpm and is driving a cast iron gear at 150 rpm. The teeth are to have a standard 20-degree stub involute profiles and the maximum power to be transmitted is 25 kilowatt. Determine the module and phase width. Find the dynamic and wear load also. The pinion has 16 teeth with surface hardness of 250 bhn. Take static stress for pinion as 103 megapascal and for a gear as 55 megapascal. Assume EP 96 giganewton per meter square and EG, that is Young's modulus for gear is 207 giganewton per meter square. So first of all we can go through that question and identify what are the given parameters. In our question, the pinion, the material for the pinion is cast steel and material for the gear is cast iron. So the material are two. So different materials are used for this gear system. And the speed for the pinion is 900 mm. So we can write the given value, the N1 as 900 mm, 900 rpm, and the speed of the gear that is given, that is equal to 150 rpm. So we can write N2 is equal to 150 rpm. Then the value of alpha, pressure angle, is given 20-degree stub. So the tooth system is also given 20-degree stub involute profile system. And next one, the power is given, power is equal to 25 kilowatt. So we can write P is equal to 25 kilonewton, and they given the value of number of teeth. The number of teeth on pinion is 16. So we can write Z1 as is equal to 16, and next one, they given the value of surface hardness. The value of surface hardness is 250 bhn. So we can write it as a bhn1 is equal to 250. Then they given the value of stress of gear and pinion, that is equal to 103 megapascal and 55 megapascal for a gear. So we can write sigma d1 is equal to 103 megapascal and sigma d2 is equal to 55 megapascal. In this question, they are given the Young's modulus also. We can use this Young's modulus to find a particular value. I can show it in a problem. Show that in this problem. So write EP, or we can write it as Young's modulus of pinion, denoted by 1 in our case. So we can write it as E1 is equal to 96 giganewton per meter square, or we can write it as a 96 into 10 raised to 3 megapascal, because we know that mega newton per meter square is a megapascal. So we can convert it into 10 raised to 3. Okay. Then E2, that is equal to 207 into 10 raised to 3 megapascal. Then they are asking what is the value of module, what is the value of phase width. Then they are asking about find the dynamic load and wear load. Dynamic load and wear load we can denote as FD and FW. So these are the given data. Now we can start our problem. The value of speed ratio, speed is given of both gear and pinion. So we can write I is equal to N1 by N1 divided by N2, and already we know that the N1 and N2, the ratio of N1 and N2 are inversely proportional to the ratio of diameters and ratio of number of teeth. So we can write it as D2 divided by D1, that is again is equal to Z2 divided by Z1 related to number of teeth. Thus we can find the value of Z2. What is the value? Z2 is equal to I into Z1. I is the value of 900 divided by 150, that is equal to 6 into 16. So we will get the value of number of teeth on gear as 96. Then next we have to identify what is the which one is the weaker section. So to find the weaker section, we need to calculate the strength factor. We know that strength factor is equal to sigma d into y. Okay. So for each case, that is for a pinion and gear, we have to find the strength factor value. So already question already given that the value of alpha is equal to 20 degree step to system. So we can take the value y is equal to 0.175 minus 0.95 divided by z from our data book from this equation. Okay, and we can calculate that value y1. We will get it as 0.1156, and similarly we can find the value of y2. The only parameter is variable parameter is the value of number of teeth. So z1 for y1 and we can use z2 for y2. So finally we can conclude the value of y1 and y2. For a pinion, the strength factor is 11.91 megapascal, and for a gear the strength factor is 9.08. So from this condition we can identify the lesser value. Which one is lesser? The gear value. The strength factor for a gear is lesser, that is 9.08. So our design is based on gear only. So next we can identify, we can find out all the values for a gear. First of all, we have to find the value of module using this equation. From the data book we can take equation number 12.16, and from page number 163 we can take the value of module m. So for this equation we need mt, sigma d, cv, k, y and z power. The mt, we can calculate the value of mt from power. Power is equal to 2 pi nt by 60. Here we are using n2. Why? The question in the first session we identify the gear, second gear, the second value, that is the gear is the weaker strength factor. So we have to select n2. We have to use n2 here to find the value of mt. Thus we can find the value of mt. Then next we can we can assume that the value of k is equal to b by m. Almost always, all problems for this per gear we can take the value of k is equal to b 10, and for a helical gear we can take the value of k is equal to 15. So here our problem is related to per gear only. So we can take the value k is equal to 10 and assume cv is equal to 0.5. It is also not given in our question. Now we can assume the value 0.5, then the form factor that we can find out, because the y we already calculated the value of y2. Then we can multiply that y2 with the pi, then we will get the value of form factor y. Next we can find the value of module using that equation. If you use the value in this equation, we can find the value of m, that is equal to 6.15 mm. Then using our data book table 12.2, we can standardize the value of module, the upper value. So in our data book they are given 8 mm as the standard value. So we can take that value, the module as 8 mm. Next one, the PCD, that means the pitch circle diameter. Using this equation, that is d1 is equal to m into z1, we can find the value of d1. Similarly we can find d2. Then face width b is given, because the k, we know that the k is equal to b by m, that is assumed value. Using that equation we can find the value of b, that is face width. These three values we can calculate immediately after calculating the value of module. Then we can go for the actual CV value. First we can assume that check for CV value. We already assumed CV is equal to 0.5. Now we can calculate it from this equation, that is V is equal to pi dn divided by 60. and for a gear the value of V is equal to 6 meter per second. So using our data book we can take the value of CV for less than 8 meter per second, that is equal to 3.05 divided by 3.05 plus V. So here we got V is equal to 6 meter per second. So using this equation we can calculate the value of CV, that is equal to 0.337, and in this equation, that is Ft is equal to pi into sigma t into C into B into Ym. We know that all other values, some values are given in our data of the question, in our data itself, question data itself, and the next values we can calculate it. Finally we can find this value Ft is equal to, we will get it as 4144.66 Newton, and using this section we can find the value of sigma d2. Then sigma d2 we will calculate it as 37 megapascal, so which is less than the given value. Given value is 55 megapascal, so the calculated values are less than the permissible, so the assumed values are satisfactory. So design is safe using this situation. Now this situation we can say that our design is safe, so we can go for further calculations. Using that we can find the value of phase width, that is equal to the module we calculated taken as 8, so we can calculate the value of phase width, that is equal to B into 10 into M, that is equal to 80 mm. Then next one we can calculate the dynamic tooth load. Dynamic tooth load Ft from this equation in our data book table 12.33 that shows what is dynamic tooth load. So Fd is equal to Ft plus K3V into C into B plus Ft divided by K3V plus root of CB plus Ft. But here the value of K3, that is equal to 20.67, it is already given in our data book. And next one, the value of V is equal to 6 meter per second, and the value of error is equal to 0.0590. This value is used because in our question they are given the Young's modulus, so we can use this equation. This equation is also shown in our data book, that is equal to C is equal to E divided by K1 into 1 divided by E1 plus 1 divided by E2. So using this equation we can find the value of C. Using that C and that value we can find the value of Fd, that is the dynamic load. That is the first question. And second section, what is the value of wear load? Also the question is already shows the value of Fw. In our data book they shows that equation Fw is equal to d1 b into q. So you can take the value directly from this equation directly from our data book, and the value of this value d1 b, and q is given, but the value of k you have to calculate from this section. K is equal to sigma es square sin alpha, and for a steel cast iron all these values are given. So using that value we can find the value of K1, and as the D2 using D, that means diameter or number of teeth, we can find the value of Q also. So using this equation we can find the value of wear load. Safety for the wear load is check Fw is greater than or is equal to Fd. In our case Fw is 24.92, which is greater than the Fd. So our design is safe and material selection also good. Thank you.